Okay, don't you love it when a video starts and the first thing that happens is that thing spazzes out and moves? All right, so next we're going to talk about graphing unions. So union, if you remember from the first video, has to deal with OR statements. And OR is the Venn diagram when two things meet. Basically anything that's in either circle is included. So sometimes they'll have a shared area, right? But you could also have an OR situation where they're like this, right? But you still include all this stuff. So OR is like one big happy family. So I think a real good example of how to think of OR is supposing you've got a bag of red marbles that has, or a bag of marbles that has some red and green marbles in it. And then your friend has a bag of marbles that has some red and blue marbles in it. Okay? Now the and, or the intersection of those two bags of marbles would just be the shared marbles. So what's the same between the two of them? What's the shared experience? So it would be the red marbles, right? Now, as opposed to the OR, a union is like, oh no, everything's welcome. So it's like taking both bags of marbles, dumping them all into one big bowl and being like, yay, marbles, right? So that's the difference, all right? OR is all-inclusive and is selective and includes only the things that are similar between the two sets. Okay, so when you do an OR, it's usually already broken up for you, right? So this has two statements here, and so basically you're just going to solve both the statements, right? So let's do that. These are multi-step equations now, so let's see where that gets us. So let's subtract 7 from both, get 6, negative 2m. Divide by negative 2. Because you're dividing by a negative number, you're going to flip that sign around, right? So you get m is greater than or equal to negative 3. And then over here, you have 5m plus 12 is greater than 37. So if we subtract 12, that gives you 25. 5m is greater than 25, and not m. My brain's not working. Been a long day, guys. Divide both sides by 5, and you get m. It's greater than 5. All right, so these solution sets usually look a little different. All right, so this is saying m is greater than negative 3. So if I make this 3 over here, that would make this 0, and that would make this right here 5. Okay, so m is greater than or equal to negative 3. So I'm going to fill in a circle at negative 3, and it's going to be everything moving in that happy direction off towards positive infinity. Now, the thing is, m also moves in that same direction, but it doesn't start until 5. m is greater than 5. So there's an open circle that would go there, and then that goes off that way. So what you have to ask yourself when you have a situation like this is, okay, how can I summarize this in the most neat way possible? Well, you really don't need m is greater than 5 on here because it's already included in m is greater than negative 3. 5 is in that set. 6, which is greater than 5, is also greater than negative 3. And you can see that anything that falls in the solution set for m is greater than 5 already falls into the solution set for m is greater than negative 3. So all you need, really, to specify this is your solution set is m is greater than negative 3. And that's just all there is to it. And that is the solution set, right? And then if you graph it, you're only going to have one dot to show because everything else is included in it, and you just got a fat line that goes this way. And like I said, heads off towards positive infinity. So that's a really good example of how OR looks. All right, let's look at another one. So 5n minus 1 is less than negative 16, or negative 3n minus 1 is less than 8. So let's do these. All right, so let's add 1 to both sides. And then you have less than negative 15 is 5n. Divide by 5, you have n is less than negative 3. And then on this one, we're going to add 1 to both sides. You get 3n is less than 9. Or negative 3n is less than 9, my bad. And then you can divide by negative 3, and then you're going to get n is now greater than negative 3. So we have n is less than negative 3, and we have n is greater than negative 3. Now this is interesting. Okay, so if this is negative 3, that means that the first one would be an open circle and going this way, right? The one on the left, the n is less than negative 3. So this is n is less than negative 3. N is greater than negative 3 would also have an open circle because it does not include the number negative 3, but then goes off this way. So you've got something going off towards negative infinity this way. You've got something going off towards positive infinity this way, right? So basically, your solution for this is everything except the number negative 3. So the way you would write your solution for this is you would say all real numbers, right? And then you would say except for n cannot be equal to negative 3. All right? Everything else works, but not negative 3. So for some reason it rejects that number, but it likes everything, and I mean literally everything else, just not negative 3. So this hopefully explains union to you guys and kind of like some of the different things you'll see for this. Good luck with these. It's not uncommon for a union when you draw a line. It's not uncommon to have something that looks like, you know, you got something going this way and then maybe you got something over here that looks like this. That's pretty regular, all right? So like I said, good luck with these and you'll do well.